Whichever ones you feel like taking out. If you can't find them, start a whole brand new one. You can add it to what you got and just have another one there. This is multiplication. Looks like you've got at least 2 already. This one, the little subheading, is multiples of, I guess it should be multiplying by multiples. This is the nice thing about this little board. Multiplying by multiples of 10 and 100. And the little subheading means absolutely nothing to you unless you know what multiples of 10 and 100 are. Does anybody tell me what multiples of 10 and 100 are? Have we done multiples? We've done multiples, haven't we? Maybe we haven't done multiples. Maybe I should just tell you rather than let you wander in some sort of vast darkness. Let's do this. Multiples of 10. Multiples are nothing more than counting by 10. So multiples of 10 would be 10, 20, 30, 40, 50. Just like multiples of 100 would be 100, 200, 300, 400, 500, and then it goes on forever there. You could do the same thing. We might as well I'll just throw it down here. Multiples of 1,000 would be 1,000, 2,000, 3,000, 4,000, dot, dot, dot. And what we're looking at is what happens when you multiply by any of these things. For example, if you would have 45 times 30. I don't believe we've done double-digit multiplication yet, and we don't need to just yet. We'll get to that. Because 30 is a multiple of 10, the little helpful advice that the book gives us when we do this is just the same as multiplying by 3, except you have that extra 0 there. So here is what you need to write in big letters. Let the 0, and you'll get this because you do this all the time, hang out. I'll let you write that down and then we'll talk about just exactly how easy this is. If you have 45 times 30, when you write it, you're not going to multiply across, you have to multiply with it up and down like this. You write it like this. When a number ends with a 0 or a bunches of zeros, you put those, slide those over so that they hang over the edge. You don't line them up like you would put the 45 and the 30 right over top of each other. You put the 0 away from that 5, that last digit, move it over 1. And then, to do the problem, you just bring that 1 0 down and multiply by the 3. So it's the same thing as 45 times the 3 with just that 0 added on the end. So then 3 times 5 is 15. 3 times 4 is 12, plus the 1 is 13. It would be the same if you had 45 times 300. Always put this one on the bottom. 45 times 300 would look like this. You'd hang out 2 zeros there. Mrs. Stone knows this because she's a product of Saxon math.
I love it.
You hang over those 2 zeros, bring them straight down, and multiply by the 3, which will give you those same digits we had over there, 13,500. Mrs. Stone, would you like to, do you need some lemonade?
No, I'm returning this in case you were missing it. I'll put it back in your back office.
I don't know where it came from nor why I have
It
it.
was in your back office and I borrowed it. I know I washed it.
Thank you for that. You want to clean my back office while you're there?
Not today, but yes, I would be more than happy to help.
Someday.
Give me about 2 weeks and
I'm gonna one of these days. Ethan would like to donate something. What was it, Ethan, you were saying?
Mrs. Mooch, she taught us on how to.
Yeah, probably so. Is there mold on it?
No. I watched it, it was, well, it could be inside there, that might have water.
Yes, Mrs. Lutz probably talked to this is probably nothing new. But remember, that works with anytime you just have one digit followed by a bunch of zeros. So this would be true if you had 45 times 3 million. You would do the same exact thing. As long as there's only one digit that's not a zero, you could write it the same exact way, 45 times 3 million. All those zeros that hang out, hang over, maybe it was hangover. Hang out? Hang out? Hang out. No, somebody said hangover, somebody said hangover, whatever it is. You just bring those 6 zeros down and multiply by that 3. Make sure, by the way, when you get more than 4 digits, make sure you're putting those commas in there, otherwise numbers get really hard to recognize. So this, what you're saying to me is this really should not be very difficult.
It's not.
Now, please note, how about this one? 400 times 37. Because of what property of multiplication am I allowed to I can either write this problem like this, or I can write this problem like this. Because of what multiplication property is it? You've only got 2 to choose from, maybe 3. Ellie Stewart? Associative property always has parentheses. Do you see parentheses anywhere there? There you go, yeah, the commutative. Commutative means you can move them around. Associative always has parentheses that move places. Numbers stay the same in associative. Commutative means they move around. You probably don't want to go this route, let me just say, because we haven't talked much about it when you have double digit multiplication and all that. So always, for right now, but even when we do double digit multiplication, this is a little bit easier to do. Bring down those 2 zeros, multiply 4 times 7 is 28, 12 plus 4 is 14,800. Correct? Everybody kind of good with that? Let me see if there's anything. I don't think that is the whole ball of wax. As it might be. Oh wait, maybe they do give you something else. Hold on, give me one more second. No, they don't. Yes, they do. No. Yes. No. Yeah, no. No. So I'll get you.